Welcome to the deep dive. Imagine you've got this brilliant idea, maybe for a 3D model, or a clever little electronic circuit, or even just automating something simple. But then you hit that wall, right? The expensive software, the really complex interfaces, maybe needing specialized kit. Well, what if there was a powerful, and I mean free, and incredibly intuitive platform that just removes those barriers? Today, that's exactly what we're plunging into, TinkerCAD. Our source for this is a fantastic article, TinkerCAD, 3D Design and Electronic Simulation by Angela from Sunshine Digital Services. And our mission today is really to uncover how this browser tool isn't just easy, but how it actually changes the game for learning and creating in STEM.
Yeah, what's truly revolutionary about it, TinkerCAD from Autodesk, it isn't just that it makes tricky areas like 3D design or electronics accessible, it's the way it gives you that immediate, almost visceral feedback. You're not just like learning concepts abstractly, you see the results right away. It bridges that gap, that really crucial gap between theory and actually doing it. Few tools manage that so well.
Okay, right. Let's unpack that a bit. What is TinkerCAD, fundamentally? Our source, Angela's article, it describes it as totally free, cloud-based.
Yeah.
Runs entirely in your browser, so no downloads, no installation hassles. It's like this unified space for making 3D models, simulating circuits, and writing Arduino code.
And that's just crucial for anyone wanting to get started without friction. Think about it. No hefty software install, no need to be a CAD expert already, and it costs nothing. Angela really hammers home that it's ideal for beginners. So perfect if you're a student just starting out or a hobbyist, maybe an educator looking for a really engaging tool. It basically democratizes access to these fields that used to need serious investment.
Gotcha. So it's not just one thing then. It's like this powerful trio of tools baked into one.
Ah,
Let's dig into those core features. Maybe start with the 3D design part. The source explains you can just drag, drop, combine shapes, or build totally from scratch.
mhm.
And here's the kicker. You can export these models as STL or OBJ files.
Right, and being able to export as STL or OBJ, that's vital. These aren't just random file types. They're basically the universal language for 3D printers. It means your design isn't trapped inside TinkerCAD. You can take it, print it on pretty much any desktop 3D printer. So your virtual idea becomes this tangible thing you can hold, and that physical part, that's a powerful learning loop, lets you refine things in the real world.
Okay, so you've made your object. But what if you wanted to actually do something? This is where, for me, it gets really interesting. The circuit simulation.
Yeah.
The source highlights you can simulate Arduino circuits with this super intuitive drag and drop interface.
Yeah.
And it's not just static, right? It offers real-time voltage, current analysis. You can add components, sensors, LEDs, motors, resistors, like a virtual breadboard.
Yeah, exactly. And connecting that to the bigger picture, the simulation part is just invaluable because it lets you experiment and even fail, right? But in a totally virtual, risk-free space. You learn how circuits behave, you can troubleshoot problems, understand the fundamentals, Ohm's law, Kirchhoff's laws, that kind of thing, all without needing any physical hardware to start. Saves time, saves money, and, saves the frustration of accidentally burning out a component. What's really great is how fast you can iterate. You change something, you immediately see the effect.
That real-time analysis sounds incredibly powerful. But is there a point where maybe TinkerCAD simulation might diverge a bit from real-world stuff, like for really complex circuits or maybe high-frequency things?
That's a really great question, a very insightful one. So while TinkerCAD is fantastic for getting the fundamentals down, and for most, say, school-level projects, you're right. Highly specialized stuff, or maybe extremely high-frequency circuits, those might still need physical prototyping eventually, or maybe more advanced, dedicated simulation software. But TinkerCAD is this incredible first step. It's where you validate your core logic, learn the principles, it builds that confidence and understanding, without those initial barriers we talked about.
Makes sense. Okay, and the third piece of the puzzle. To really bring these creations to life, code blocks and Arduino programming. The source points out that beginners can start with visual blocks, like puzzle pieces, but then you can actually switch seamlessly to text-based code, specifically CC++ for Arduino. So you can program behaviors and see them simulated in your circuit.
Yeah, and this dual approach, it's brilliant for learning progression.
No.
Starting with visual blocks makes coding way less intimidating. It builds confidence in just thinking logically, but having that option to just flip over to text-based CC++ click that prepares users for, more advanced professional programming environments. It's a really smooth path from basic control flow to writing actual functional code for physical computing. This really unlocks that smart world for a lot of people, teaches the foundations of automation, IoT.
Okay, features are one thing, but what can you actually do with it? especially if you're, say, a student or just someone messing around. Angela from Sunshine Digital Services gives some great examples here. For 3D modeling, you could design, I don't know, custom keychains, small mechanical parts, even quite complex architectural models, apparently. And that doesn't just teach design, right? It helps you get your head around geometry, measurements, practical problem solving.
Oh, absolutely. Think about those aha moments, like when you design a little mechanical part and suddenly realize why the geometry has to be that way for it to work physically. It just instantly shifts learning from abstract textbook stuff to something practical, applied knowledge that actually sticks.
And for the circuit design and testing part, you can learn to build and test basic electronics without ever touching real hardware first. Imagine, like, simulating a simple battery, powering an LED, or maybe a temperature sensor, feeding data to a virtual Arduino, and seeing it work or not work immediately.
It's a massive benefit for learners. It lets you iterate so quickly and safely. You immediately see what happens if you change that resistor value or tweak the voltage. That instant feedback just accelerates understanding of basic electrical principles. It's like having a virtual lab right there.
Right. And the source also highlights that for the Arduino programming side, you can practice microcontroller basics, automate things like lights, fans, maybe sensors using pretty simple code logic. It's all about bringing ideas to life, step by step.
And this is where that smart world really starts opening up for people. Learning to automate even simple tasks with code, that's the foundational skill. It's what you need to understand and eventually build more complex smart devices, IoT systems, all that stuff. It turns abstract lines of code into actual real-world control.
Our source, Angela's article, goes on to say TinkerCAD is basically perfect for academic projects. Because it's so beginner-friendly, it works from middle school right up to university-level stuff. Requires zero installation, gives you that real-time simulation immediate feedback, and it even integrates with other Autodesk tools, which kind of hints at a pathway to more pro software later on.
Yeah, that really highlights its versatility and its solid educational value. Immediate feedback, especially when you're designing something or working with electronics, it's just paramount for effective learning. It allows for that rapid iteration, that deep understanding of cause and effect, which honestly, traditional classroom setups often struggle to replicate that well.
And it's not just for general learning, is it? Angela's article outlines some specific applications for STEM and engineering students. We're talking about things like prototyping actual smart IoT devices, designing and simulating smart home systems, building school-level robots or automation models, even creating custom 3D printed enclosures for the electronic projects you're building.
Exactly. This shows how a tool that feels foundational can actually scale up. It can help tackle pretty complex engineering challenges. So it's not just for the absolute basics. It's a genuine stepping stone into advanced areas like smart systems, robotics. It lets students tackle ambitious projects, but within a framework that's accessible and, crucially, forgiving. It really bridges that gap between theory in the classroom and practical engineering hurdles.
Okay, so pulling this all together, what does this mean for you, this listener? We've sort of explored how TinkerCAD, this totally free browser-based platform, it just completely lowers the barrier to entry for 3D design, electronic simulation, and coding. It's this really hands-on environment packed with features from visual coding to that real-time circuit analysis. Makes it pretty much perfect for learners at all levels, wouldn't you say?
Absolutely. It really emphasizes applied knowledge, critical thinking, by just letting you experiment, innovate, and, importantly, fail safely, all without the usual upfront costs and the complexities you get with traditional engineering tools. It fundamentally changes how individuals can actually engage with STEM fields.
Yeah. Our deep dive into this source in Angela's article, it really reveals that, you know, mastering basic 3D design or understanding how a simple circuit works, it no longer requires shelling out for expensive software or having access to specialized labs. So what if the most powerful tools for innovation, for learning, are now just a browser tab away? Completely free, accessible to basically anyone with an internet connection. What will you build now that those tools are truly within reach?